All right, so we got a piecewise function. X is great. I'm just going to write this down. Negative x plus 2, x. Okay. Okay, so let's sketch it first, and then we'll find the limit. Okay. So it looks like, so if x is less than negative 1, then our graph is x plus 2. So negative 1. 1, 2, 3, 4. Okay. So if x is less than, yeah, just give me a second. If x is less than negative 1, so if it's like negative 1, negative 2, negative 3, then our graph is going to equal x plus 2. So if you have trouble graphing this, you could graph the whole thing and then erase what you don't need. So like, Victoria, can you just wait a second, please? Sorry, I can't work at home with children. Okay, so x plus 2 is our line. So 2 is our y-intercept, and our slope is 1. So I'm just gonna, that's what my graph would look like, right?
Right.
You just had to graph like y equals x plus 2, because our slope is 1 and our y-intercept is 2. Except it's only when x is less than negative 1. So you'd have to, I can't do this on my silly Notability, just erase this the whole thing. You'd have to, anything prior to negative 1, you'd have to erase. So that would be the only part of your graph. And I'm going to put an open circle here because it says when it's less than, it doesn't say less than or equal to. So I'm just putting an open circle indicating that my graph doesn't actually touch negative 1. And then the other part of my graph is negative x plus 2. So my slope is negative 1 and my y-intercept is 2 again. But this is x is greater than or equal to negative 1. Okay, so I got a y-intercept of 2, and then my slope is like down 1 over 1. My slope's going like that. And it's only when x is greater than or equal to negative 1. So it actually does equal negative 1. It's got that equal sign. So it would look like this. Does that make sense? The graph?
Yeah.
How do you know the line's going that way?
Because the slope's negative 1. So I know, like once I plot my y-intercept of 2, I know that a negative slope goes down to the right and a positive slope goes up to the right. So I know that I would go like down 1 over 1 to get my next point. Down 1 over 1.
Wait,
Does that make sense?
For m, you just knew it was negative 1 over 1, right?
Yeah, exactly.
Okay.
Yeah, you can always put your slope over 1.
Okay, that makes sense. So would that be the same for all? Because, like, also like for b as well?
Yeah, be like negative 1 over 1 and negative 2 over 1.
Yeah. So it says determine the indicated limit if it exists.
Right. So it wants to find out if the limit as x approaches negative 1 of our function. So what do you guys think? Does the limit exist?
No.
You're right.
Because the two lines don't meet at negative 1, 1.
Yeah. So because as you approach from the left side of the graph, the yellow's rough. So as you approach from the left side, being like, okay, what happens when I get close to negative 1? Well, this graph seems to approach 1 on the y-axis. But this side, if you approach from the right side, this side approaches 3. So the left-hand limit is equal to 1 and the right-hand limit is equal to 3. So if the left and the right-hand side of the graph don't approach the same y value, then your limit does not exist.
Okay.
Because you can't definitively say like what each side approaches as you approach this value. They approach like 2 different y values. Does that make sense?
Yeah.
Yes.
It's weird, yeah, but
Okay.
do you guys want to try another one or no?
Can we do same page, number 5, please?
Number 5?
Yes.
Is that the determine the limit as x goes to 4?
Let me pull up the question.
Hey, why are you freaking out?
Yes, it is.
Okay. Yeah, we totally can. Okay, perfect. Just making a water delivery for my kids. Quick. Hey, water delivery. I think yours is the pink cup. Okay, have the blue cup. Okay. Okay, question 5. The limit as x approaches 4 of f of x and f of x equals 1 if x doesn't equal 4. What? And -1 if x equals 4. That's super weird, huh?
Mm-hmm.
Yes.
I checked
Okay,
the back
listen.
of the textbook and it said 1, and I was confused. I'm like, I don't know what's going on.
Yeah, and I couldn't do that question.
Okay. I'm just gonna try to draw it if I can. Okay, so basically we got y equals 1, which is a horizontal line,
Mm-hmm.
when x doesn't equal 4. So it looks like any other values other than 4 gives us this equation. And then we got y equals -1 if x is equal to 4. So I'm just gonna put that smaller. So you actually would just have a dot here, I guess, because -1 if x equals 4. Look, this is the weirdest graph of all time. So it says determine the limit as we approach 4. So the reason that the answer is the answer 1, you said it was?
Yeah.
Yeah, okay, so that makes sense because to determine a limit, if you can't figure it out just by looking, then you can look at the left hand limit and you can look at the right hand limit.
Mm-hmm.
And as long as they approach the same value, then that's the answer. So if you go from the left side of the graph, you're approaching 1 as you get closer to 4.
Mm-hmm.
And then if you go from the right hand side of the graph, you're also approaching 1. Because this guy, this random point right here, like he's not really on, like as you approach from the left and the right, you wouldn't start at that point. So even though there's an actual point there, that's not the limit. So the limit is equal to 1 because that's what you approach from the left and right side. So even though it's like, that's so weird, a limit, it doesn't have to equal that value.
Yeah.
It just has to approach it from the left and the right. But this would tell us that since the limit as x approaches 4 of f of x is not equal to the value at f of 4, like those values are not equal because the limit equals 1 and then f of 4 is actually -1. That just tells you that the function is not continuous, like not a continuous function.
Is there a line on the bottom one?
A line?
One? Yeah, is there a line for that one,
No,
or
it's
just
a dot.
how do you know that?
Because it just says only when x is equal to 4 that y is equal to -1. So like if you were to make a line, it would hit other x values, but you only want it to hit one x value.
Oh,
Like
okay.
if you did a line like this, like now that equals 4.1, 4.2, 4.3, you know, like since it's only when it equals 4, anytime you see like the equals part, it will always just be a dot.
Okay.
That is a weird question.
Okay.
I find all the limits ones are kind of weird.
Yeah. Sorry. Another question is on
Yeah.
page 45, number 1.
45.
Like I kind of know why, but it doesn't really make sense because it's saying limit and then bracket, like a parentheses, 3 plus x.
Okay. Are there different answers for the limit as x approaches 2 of 3 plus x? X plus 3. So are there different answers?
Well, I think like from my opinion, I think there's like limit 3 plus x, like limit as x approaches 2, like 3 plus x is the same as the limit of x plus 3.
Yeah.
But like the one in the middle is different because like there's no bracket, I guess.
So you think this one's different?
Yeah, from the other two because the other ones are, I think, like practically the same thing. They're just like rearranged differently. But since
Right.
there's a bracket, it's technically the same. Whereas this one doesn't have a bracket, so like the x, I don't know. That's where I'm getting confused.
Yeah, this one is weird. I definitely agree with you. Like these have to be the same because who cares which way you add? Like they're definitely the same. I agree. And then this one, I'm just thinking about it. Sorry. I think, okay, I'm just looking at the answer. Sorry. Okay, this is like a technicality. This is saying because, not a technicality, but it's saying because, honestly, I didn't even think of this. They're saying because there's no brackets, that it's just asking you for what's the limit of 3, and then plus x is not even a part of the limit. So they're saying like whatever you want to include in the limit has to be in a bracket. So basically this question's saying what's the limit as x approaches 2 of 3? And then they're just adding a random plus x. So it's almost like the bracket's here.
All right.
So then this, you can't even sub anything in because you don't even know what that means. That's kind of a silly question.
All right.
Sorry if I assigned that.
Why can't you sub in 2 for that x then?
Because they're saying that they're just asking for the limit as x approaches 2 of 3, not of x.
So it's like a separate, like it's on its own sort of thing?
Yeah. So this would be equal to like, well, the limit as x approaches 2 of 3 is just 3. And then you would just write plus x because you don't even know what x is.
Right.
Whereas in these ones, you could sub in 2 because they're asking like for this whole limit. Like, what's the limit of this whole thing?
Okay.
I guess it's kind of a weird thing. Or I guess they could have written it like, what's x plus the limit as x approaches 2 of 3. It goes on top of the, yeah, I'll put it away. Thanks for cleaning up.
By myself.
I know.
Clean up the barbers.
Thank you. Do you guys have any other questions?
Yeah. It's I don't know if it's from the like practice quiz. Like I did the 2 last ones, but like the first question was like determine the limit, state the domain, justify that f at x is not continuous.
What?
Like,
What question was that?
the practice quiz, the one that you have is that's due at 11:30 today.
Oh, okay, wait, I'm going into it. Can't even remember it now. I didn't even know I put limits on it. Did I? I guess
Yeah,
so.
for the first one, it's like you gave us a graph. The one that we kind of did like for 11A kind of looks like that.
Is it the average and instantaneous rate of change? That one?
This one, it says A1 investigating instantaneous rate of change at a point.
It's a quiz?
Yeah. It's the very last thing in A1.
Oh. Oh. Does it take you to another website?
Uh-oh.
Okay, wait, I'm going to it. Sorry, I completely forgot what this is. That's really bad.
What's the number of the question?
Oh, it's a worksheet.
Yeah.
Right. Okay, I remember now. Yes. Okay, I gotcha. I forgot about that. Okay, so which question is it?
It says giving the following function, then like f at x equals negative x plus 2 if x is less than 2.
Okay.
Yeah.
This one. All right, awesome. Okay, so you just want to know how to do this part?
Yeah.
Oh, sorry, I opened it on my... Ew, it looks horrible. Is that what the equation looks like for you guys with these question marks? What did I make this in? I gotta fix this. Okay. So it's supposed to be what's the limit as x approaches 2 from the left, I think. Did yours come out all messed up?
Yeah.
Okay. I'll fix it. I didn't even know that. Okay, so it's supposed to say that. Okay, so
when
the
you
limit
download it in,
yeah, if you download it, does it work better?
yeah,
Okay.
it's
Okay.
too negative.
Okay, perfect. Yeah, what's up? Okay.
Yeah.
Sorry, just quick.
Hello, hello. Where are the faces, Mommy?
Can't see anyone's face. Okay. So if you're approaching 2 from the left, what do you think the answer would be?
2 from the left. Let's see. Would it just be -2?
How come
Or-
you think -2?
Because for one of my questions in the textbook, it said calculate each limit if the limit of x and then as x approaches -5, and the answer was -5.
Oh, that was just random.
Random? Okay, so no, that doesn't make sense.
Okay, so if you're on the left side of the graph,
Yeah.
find the line that's closest to the left side of the graph. So, like, would it be this line or this line?
That one, the left one.
Yeah. And then you just follow it until you get to x equals 2.
Okay.
So there's x equals 2.
Right.
And then you look at what y value are you at?
Y value, you're at 0.
Yep. So then it's 0.
Oh, okay.
Does that make sense?
Yeah, that makes sense.
And then if you're going to do it, sorry, what?
So, and then for B, if it was like, if x approaches 2, that means it's the right one as it's a positive, right?
No, because it doesn't have a positive here.
Okay.
So if it was asking you for the positive or from the right, we would have a plus sign.
Okay.
Well, let's just try that one. What do you think it would be if you're approaching from the right?
The y value would be 2.
Yeah, that's right. So if you're approaching from the right, then you're at 2. So what does it tell you if your left-hand limit is 0 and your right-hand limit is 2?
Yeah.
Then if you had to answer this question, what's the limit as x approaches 2? What would you say?
As x approaches 2. Yeah, probably 1, right?
Yeah, you would think, but no. It actually doesn't exist. Because...
And what's that dot on the graph?
Yeah, it is a value at 1, but it's not the limit. It's just when x is equal to 2, then your y value equals 1. But unfortunately, to to find the limit as x approaches 2 means that. You want another one? Is that what you came here for?
Seriously say that.
Well, I'm just trying to get rid of you.
Okay.
Okay, sorry. So the limit is if you're approaching a value from the left
Yeah.
and from the right, they have to meet at the same value in order for that limit to exist. So since you have a graph that approaches 2 and it gets to 0,
Yeah.
and then you have a graph from the right that gets to 2, since those two values are different,
Yeah.
then you can't have a limit at 2.
What if they were both zeros? Does that exist as well?
Yeah, then you'd
Okay.
be good. Yeah,
Okay.
so if like, for example, if this line actually came down and went to here,
Yeah.
then that would equal 0.
Okay. All right.
So this dot right here, it doesn't really matter. Like they don't really have any significance on limits. They're just a point on the graph.
Okay.
Do you guys know the answer to this?
Domain, would it be like
XCR?
is not a real number? Wait. Yeah, would it be XCR?
Yeah. Although I should have put arrows like this. But yeah, it would be. Cool. Any other questions?
Well, for D, it says justify the f at x is not continuous. By justify at x equals 2. Oh,
Yeah,
is
so
that
if
what
you-
you just told us?
Yeah, so if you have to prove that a graph is not continuous,
Yeah.
then basically you just have to show that its limit as x approaches 2
Not even.
of f of x is not equal to the value at 2. So the limit as f of x approaches, or as x approaches 2, first of
Yeah.
all, that limit doesn't exist. And the actual value of f of 2 is 1. So since those two values aren't equal, then it's not continuous.
Okay.
Because if you think about a continuous graph, like if you actually had like a quadratic, say you were looking at when x equals 2, you can see that like from the left-hand side, let's just say you're approaching like -3. And from the right-hand side, like they're both approaching -3.
Mhm.
So your limit as x approaches -3 of f of x. Oh, I didn't mean to put that. As x approaches 2, sorry, is equal to -3. And then your value at 2, like f of 2, is equal to -3.
Mhm.
So since these things are both equal, then it's a continuous graph.
Okay. All
So
right.
like your left hand and your right hand limit have to be the same, and the value of your graph at 2 has to be the same as your limit.
Okay.
Anything else?
I think that's good for me.
Sweet, that's awesome that you jumped on. I feel like poor Sanzeed's been the only one asking questions.
Good thing I always have them.
Yeah.
Right. Yeah. Good.
Cool.
Okay.
How are your classes going, Willie?
They're going great now. Like honestly, yeah. I'm like caught up with everything.